Lecture 13, source conversion, voltage source to current source conversion, and vice versa. So what is source conversion? So it says that we can convert voltage source in series with resistance to a current source in parallel with the resistance, and a current source in parallel with the resistance to a voltage source in series with resistance, while the load terminals remains same. So how do we do it? So when we are converting voltage source to current source, the resistance directly goes to the parallel, and the current value will become I equal to V by R, where V is this voltage and R is this resistance. And while we are converting current source to voltage source, then this parallel resistance directly goes to series, and this voltage becomes I into R, where I is the current source value and R is the resistance, while the load terminals remain same. So let's understand it with the help of a numerical. So the task of this numerical is to find out this value of IL through resistance 3 ohms, and this can easily be done by source conversion. So we can see that in the extreme left there is voltage source in series with resistance. So this will act as a load terminal. So this can be converted into a current source in parallel with the resistance. So the value of this resistance will be same as that of this resistance, that is 3 ohms, and the value of this current will be V by R, where V is this voltage, that is 6 volt, and R is resistance, that is 3. So 6 by 3 is 2 amperes. So now we can see that these 3 and 6 ohm resistors are directly in parallel, so they can be clubbed. So let's club them. So here it is 2 ampere, and this equivalent resistance will be simply the parallel combination, that is 3 into 6 divided by 3 plus 6, and this comes out to be 2 ohms. Now we have a current source in parallel with the resistance, so it can be converted into a voltage source in series with resistance. So this 2 ohms is directly written here, and this voltage value will be simply equal to I into R, that is 2 into 2, that is 4 volts. Now we can see that these two resistances are in series, so they can be clubbed and directly added, so it becomes 4 ohms resistor, and this will be 4 volts source. Now we have a voltage source in series with the resistor. It can be converted into current source in parallel with resistor. So the resistance value will be directly 4 ohms, and the current value will be the voltage divided by resistance, that is 1 ampere. Now very important point. Since these two current sources are in parallel and there is no series resistance present, then they can be directly added as the direction of current is upwards. So the net value of current will be 1 plus 3, that is 4 amperes in upward direction, and this resistance will remain as it is. Now we have a current source in parallel with the resistance. It can be converted into voltage source in series with the resistance. So resistance value remains same, and the value of voltage will be simply I, that is 4 ampere, into R, that is 4 ohms, that is 16 volts. And finally these three resistances are in series, so they can be clubbed directly. So this will be 4 plus 1 plus 3 is equal to 8 ohms, and now the current will simply be 16 by 8 using Ohm's law, and this comes out to be 2 amperes. Homework question: find the value of VL using source transformation and post your answers in the comment box.